Good morning. Today we are going to start a new chapter of the canal regulation works. So there are the different types of the contents which are included in this chapter: the canal fall, necessity, and the location of the falls, types of the falls, cross regulators and distributed head regulators, silt control devices, canal outlet, non-modular modules, semi-module, and rigid modules. Okay, so first one is what is a canal? Canal fall. Whenever the available natural ground slope is steep in the design bed slope of the channel, the difference is adjusted by the constructing a vertical fall or drops in the canal bed at a suitable intervals as shown in the figure below. Such a drop in the natural canal bed will not be stable, and therefore in order to retain this drop, a machinery structure is constructed. Such structure is called the canal fall and the canal drop. So, what is a canal fall? Canal fall is nothing but man-made structures which are constructed near the vicinity of the area when there are the no availability of the ground slope, or the ground slope is very steeper to sustain that kind of the design flow in the canal. So the canal fall is provided for the vertical fall and to contain that kind of a design discharge in the canal. Such drop in a natural canal bed will not be stable, and therefore, in order to retain this drop, a machinery structure is constructed. Such a structure is called a canal fall or a canal drop. So, this kind of the figure is shown is the vertical drop. Okay, so this is a design slope, this is the actual slope, actual available ground slope, which is a very steep. And due to the steepness, the velocity of the water is particularly very high, which also causes causes the many problems or many effect in the lining of the canal or in the surface of the canal, like the cavities and another type of the stouring and silting phenomena. So to minimize that kind of phenomena, the kind of vertical drop is provided for just to slow down or just to slow down the velocity of the water and provide a suitable discharge or a design discharge. So why the necessity of the canal? When the slope when the slope of the ground suddenly changes to a steeper slope, the permissible bed slope cannot be maintained. It requires excessive earthwork in filling to maintain the slope. In such cases, falls are provided to avoid the excessive earthwork is in filling. So, when there are certain changes are occur on the ground slope, or the certain steep slope are occurred at that particular location, the permissible bed slope, which are going to B by D ratio, are not maintained, and just to maintain that particular kind of ratio, the vertical fall are provided for just to minimize the excessive earthwork which are required at that particular location if the canal is not provided properly. In a cross drainage works, when there are difference between bed level of canal and that of a drainage is small, or when the FSL of the canal is above the bed level of a drainage, then the canal fall is necessary to carry the canal water below the stream or drainage. So there are the different types of the falls which are available, like the auger fall, step fall, sharda fall, rapid fall, straight fall, trapezoidal notch fall, well or cylindrical notch fall, Montague fall, English or baffle fall. But above this kind of about the different types of the fall, the Sharda fall is the most suitable in any kind of any kind of the situation when there are the excessive steep slope are available in the ground level. So the Sharda fall provides a provide a basic guidelines or basic standard specification of how the fall would be constructed at that particular location. So so there are the different types of the fall. The augie fall is a very easy in construction as well as in maintenance. In a step fall is nothing but a kind of a step kind of footings which are provided at the bed of the canal. But the sharda fall is a complex structure and provide the design discharge velocity uh, at a long run In the type of the construction in the construction of the different types of the fall, there are the two different methodologies which are going to affect the Kennedy's theory as well as the Lacey's theory. In that particular two theory, the both the scientists suggest that there are no silting, no scouring velocities are available in the long run. So what is the non-silting and non-scouring velocity? So when the water is flow at a very discharge rate or a particular velocity, so due to that force, the earthen material which are located at the surface of the canal are going out and wash out with the flow of the water. So the both the scientists suggest that the non-silting, non-scouring velocity is that kind of velocity that no silting as well as no scouring occur at the surface of the surface of the canal. So the Sharma fall constructed on the principle of the non-silting, non-scouring velocity. The rapid fall, straight fall, and the capillary notch fall are generally provided at where there are a loose soil are available and the proper concrete work are required to design a proper canal. A well or cylindrical notch fall and a Montague fall and as well as English fall are not very much familiar in this time because there are high chances of the silting as well as the scouring are occur. So there are the different types of the falls like augie fall, step fall, chanda fall, rapid, straight, trapezoidal, cylindrical, Montague, and English or backward fall. So next one is a head regulator. So what are the works of the head regulator? Regulators constructed at the off-taking point are called head regulators. When it is constructed at the head of the main canal is known as a canal head regulator. And when it is constructed at the head of the distributor, it's called the distributor head regulator. So what are the function of the head regulator? To control the entry of water either from the reservoir or as well as from the main canal, to control the entry of the silt into the off-taking canal or main canal, to serve as a meter for measuring discharge of the water. So when a water are transmitted from the main canal to the off-taking canal, or in the other terms, when the water is transmitted from the reservoir to the main canal, the proper regulator are provided just to maintain the water level as well as to prevent the entry of the silt material or debris materials into the canal and maintain a proper bed slope of the canal which helps to attain a kind of the critical velocity or as well as a design velocity in the canal. So there are the different types of the function of the head regulator to control the entry of the water either from the reservoir or from the main canal, to control the entry of the silt into the off-taking canal or main canal, and to serve as a meter of measuring discharge of the water. There are the different other type of the works of the head regulators like to uplift the water level in the reservoir as well as in the river, to provide a proper water at a suitable time when there are a very low or a very dead storage of the water available at the in the reservoir. So the head regulator is a very much important part of any irrigation system. There are the two types of the head regulator. When a head regulator is constructed near in the main canal, it's called the canal head regulator, and when it is constructed at the head of the distributor, it is called the distributor head regulator. So there are the construction. The components of the head regulator depends upon the size of the canal and the location of the head regulator. It consists of the one or more gated research opening with the barrels running through the bank. For large canals, head regulator are flumed to facilitate the measurement of the discharge. So with taking into account that what are the design discharge ratio and what are the sizes of the canal, the head regulator or the size of the head regulator are vary from that particular point of view. So if there are a very high ratio of the water discharge, or there are big size in the reservoir, so the canal head regulator are also provided with the number of the we provide a number of various gates, as well as there are the proper barrels are available to control this kind of the gate operation in that. head regulator. For the large canals, head regulators are flumed to facilitate the measurement of the discharge. So next one is a cross regulator. A regulator constructed in the main canal or the parent canal downstream of an off-take canal is called the cross regulator. It is generally constructed at a distance of 9 to 12 kilometer along the main canal and 6 to 10 kilometer along the branch canal. So what are the function of the cross regulator? To control the flow of water in the canal system, to feed the off-taking canal, to enable the closing of the canal breaches on the downstream side, or to provide a roadway for a vehicular traffic. So there are the different kind of the function of the cross regulator, just to maintain or control the flow of water in the canal system, which are off taking in from the reservoir or as well as from the main canal, to feed the off taking canal whenever it is required. There are if there are if there are a low water table or low water level are available, just to provide a excessive amount of water in the off-taking canal for fulfilling the irrigation need of a particular region, to enable the closing of the canal breaches on the downstream side and to provide the roadway for the vehicular traffic. So there are a different kind of construction methodologies are used. For the cross regulator, abutments with the grooves and the piers are constructed parallel to the parent canal. The seal of regulation is kept with a little higher than the upstream side bed level of the canal across which it is constructed. Vertical lift gates are fitted in the grooves. The gates can be operated from the roads. So this is called the canal regulator. So the main canal and this is the off-taking canal. The water are transmitted from the main canal or parent canal to the distributed channel or off-take channel. So the cross regulator is nothing but just to provide a control of a water into the parent canal as well as the off-take canal. And the function of the head regulator is to control the water level, in the off-taking canal or as well in the branch canal, as well as to prevent the silt entry into the canal from the reservoir as well as from the main canal. So this is a cross section of a cross regulator, that the different types of the impervious floors are constructed from starting from the upstream side to the downstream side. There are the different types of the piers, abutment, and the gates are constructed just to prevent the excessive amount of water entry from the reservoir to the main canal or as well as from the main canal to the distributary canal. The impervious floor constructed with the help of the concrete as well as the earthen material, just to prevent the piping as well as the undermining effect. So what are the piping and undermining effect? That there are the excessive water are percolating from the upstream side, the water travel beneath the impervious strata and wash out from the downstream side. So it will be cause a damaging effect in the downstream side as well as in the lining or the surface of the canal. So just to minimize the kind of the piping and undermining action, the impervious material or impervious floor are provided. There are also vertical sheet piles are also constructed at the upstream side as well as in the downstream side. So this kind of a construction or this kind of the facility are increasing the creep length of the water in the reservoir or in the main canal, just to minimize the piping as well as the undermining effect. This is a cross section of the head regulator. There are the certain difference between the cross regulator as well as the head regulator. In the head regulator, there are the certain types of the manholes are provided just to examine the head regulator or the cleaning or providing proper maintenance to the head regulator. In the top of the head regulator, there is a roadway is constructed for the vehicular movement as well as the for the people's movement, for just the checking or maintaining the particular head regulator or just the operating. Sometimes the operation room are also constructed in the top of the head regulator. So the kind of the roadway are provided for just reaching that particular operation room and to operate the head regulator for the successive purposes. Next one is a silt control devices. So the head regulator and the cross regulator are also serve as a function of the silt control devices. But there are a particular or dedicated silt control devices named as a scouring sluice and under sluice, silt pocket and silt excluders. The above three components are employed for the silt control at the headwork. Divide wall create a silt pocket. Silt excluder consists of a number of under tunnels resting on the pocket. Top floor of the tunnel is at the level of a seal of the head regulator. Various tunnel of different lengths are made. The tunnel near the head regulator is the same length of a head regulator, and successive tunnels provide the divide wall are short. Velocity near the silt laden water is disposed downstream through the tunnels and the underslope. So there are the different kind of the work which are assigned to the different silt control devices like the scouring sluice, under sluice, silt pocket, and silt excluder. So the scouring sluice and the silt pockets are constructed near or the vicinity of the divide wall, which also catches the excessive amount of the silt which are transmitted from the reservoir to the main canal. And the silt excluder is situated after the cross regulator or a head regulator, which whose work is just to remove the floating debris or the floating silt material which are inside the canal or a parent canal or the off-taking canal. So there are the three different kinds of the work are assigned in the scouring sluice, seal pocket, and the seal excluder. The scouring sluices and the seal pockets are constructed at the down level of the head regulator, while the seal excluder are constructed from the up from the higher level of the head regulator. Because the scouring sluice, the work of the scouring sluice is that the debris which are suspended into the bed slope are washed out with the help of the scouring sluice or the silt pocket. But the floating debris or the floating silt which are available at the in the water in the canal, the silt excluder remove that kind of the excessive silt matter with the help of the excluders and the vacuum system. So the various tunnels are constructed in the scouring sluice, which are related to the canal head regulator as well as a cross regulator. And the silt pocket are also constructed in the vicinity of the scouring sluice. So the silt control devices or the work of the silt control devices is to prevent the entry of the silt into the main canal or after-pin canal which are transmitted from the reservoir, and to maintain a proper bed slope to achieve the design discharge velocity of that canal, and to provide a water to the very far extent or most extent of the irrigation line. So the silt excluder is located at the upstream of the diversion weir and in front of the head regulator. The object is to remove the silt that has entered in the silting basin through the scouring sluice. Silt ejector is located in the canal takeoff from the diversion weir at 6 to 10 km in the canal reach. It ejects the silt that has entered in the canal. Canal outlet or modules. A canal outlet or modules is a small structure built at the head of the water course so as to connect with the minor or a distributed channel. It acts as a connecting link between the system manager and the farmers. So the canal outlet is nothing but when the off-taking canal are ended and the field or the water courses are started. So that kind of a structure are built at that time at that particular point. So it will be discharge of water to the force field from the reservoir to the main canal to the off-taking canal and to the water course or to the field. It acts as a connecting link between the system managers and the farmers. Non-modular modules are those through which the discharge depends upon the head difference between the distributary and the water courses. So there are some common examples of the non-modular modules: open sluice and drawn pipe outlet. So, but in the recent time, the non-modular modules are not pretty much used because there are the difference in the head in the distributor as well as the water courses. So for providing a proper water at a certain point of location, There are the kind of the modular modules like the head regulator, canal regulator, as well as the off-taking canal as well, or a branch canal are constructed. So the open sluice and the ground pipe outlet are very not very much familiar for providing a lengthy irrigation system. So this is a figure of the non-modular modules. The bed of the distributed, the bed of the water course. There are the difference in the water level. So this is the horizontal pipe or underground pipes are provided to transmit the water from the distributed channel to the water course. Semi-modules or the flexible modules, due to the construction of supercritical velocity is ensured in the throat and thereby allowing the information of a jump in the expanding flow. The formation of a hydraulic jump makes the outlet discharge independent of the water level in the water course, thus making it a semi-module. Semi-modules or a flexible modules are those through which the discharge is independent of the water level of the water course but depends only upon the water level of the distributor so long as a minimum working head is available. Examples are the pipe outlet and open flume types. When the water are transmitted from the reservoir to the parent canal and after the canal head regulator, there are the kind of a hydraulic jump is formed, and due to the hydraulic jump, the level of the water and the velocity of water are much higher than the critical velocity, and due to that particular critical velocity phenomena, there are the chances of the damage of the canal as well as the damage of the bed of the canal slopes. So for reduce the critical for reduce the velocity and down to the critical velocity, there are the different types of the flexible modules are which are used to reduce the water velocity or the water velocity discharge and provide a or to provide a proper hydraulic jump that will not enable critical velocity in the supercritical velocity, but it will be held the critical velocity in the subcritical velocity. So it will be beneficially for the maintaining the bed slope of the canal as well as the provide of water with a certain heads and reduce the entry of the debris in the canal from the reservoirs. So there are the kind of the semi modules which are used. So this kind of the construction are carried out at that kind of the distributed canal or as well as a main canal. So this kind of the hydraulic jumps are formed, and this is the impervious strata which or jump pockets which takes a destructive energy of the hydraulic jump and change the supercritical velocity to the subcritical velocity of the water and and flow to the water from the distributed channel to the main off taking canal. Rigid modules or modular outlets. Rigid modules or modular outlets are those through which discharge is constant and fixed within a limit, irrespective of a fluctuation of water level of and either the distributary or the water courses or both. Example of the Gibbs model. So the Gibbs model are provided at the vicinity of the canal head regulator as well as the cross regulator. So this kind of the rigid modules are provided just to maintain the critical velocity of the water and the fluctuate and to control the fluctuation of the water level at the distributary canal as well as from the water courses. So this is a definition of the Gibbs module. This type of the construction or the baffle plate are provided at the midpoint of the Gibbs module, and when the water are flown with the FSL full supply level. So there are the different kinds of the gates and barrages are available to dissipate the excessive or destructive energy of the water and flow the water at the subcritical velocity, which also help to power generation as well as which also help to prevent the entry of the silt in the particular area. So there are the different types of the construction are carried out or constructed at the irrigation canal, like the canal head regulator, distributed head regulator, cross regulator, Gibbs module, types of the various flows or canal falls. So this kind of the canal regulation works are constructed at the irrigation level. If you have any queries regarding this chapter, please drop a message, and we will discuss about what are the different guidelines or what are the different standard specification are given for the construction of the head regulator as well as the cross regulator. So in the very next chapter, we understand that the basic terminology and the basic principles and the methodology of the irrigation, that how the irrigation networks are work, or what are the methodology and the principle or the phenomena are going to work at that particular whether constructing a new irrigation or improving a new irrigation network. So in the very next lecture we will discussing that kind of the work. So see you at the next lecture.